So let's take to figure out the concavity, we're going to take the second derivative. I've rewritten both of the original function and the derivative up at the top here, and I'm going to have to use the product rule. So I'm going to cut the first piece into two functions, and I take the derivative of the first, which is negative 2 cos x, times the second, which is cos x, plus the first. So plus a negative 2 sine x, which will be negative 2 sine x, times the derivative of the second, which is a negative sine x. And then taking the derivative of this last piece, it's negative 2 times the derivative of cos, which is negative sine x. Now I'm going to clean this up a bit. It's negative 2 cos squared x plus 2 sine squared x plus 2 sine x. Now I notice I've got a mixture of sines and cosines, so I'm going to switch them, and there's more sines than cosines, so that means there's two places where the cosine happens. So I'm going to replace this with my Pythagorean identity. So cos squared x equals 1 minus sine squared x. So here we go, negative 2, 1 minus sine squared x plus 2 sine squared x plus 2 sine x. Cleaning that up again, I'm going to multiply the negative 2 into the bracket, plus 2 sine x squared x plus 2 sine x, and collect like terms and write it in decreasing up powers of sine. I'm going to factor out a 2. And then I'm going to factor the trinomial one more time. So it's 2 sine x times sine x. What multiplies to give me negative 1? It's a positive 1 and a negative 1. And you can test that to make sure that you've got it in the right order. I know I'm going to have to figure out where these are equal to 0, so I'm going to do that right away. When is the sine x equal to 1? So 2 sine x equal to 1, so when is sine x equal to a half? It's equal to a half at pi over 6 and 5 pi over 6. Remember, in these two quadrants with the reference angle of pi over 6. When is sine x equal to 1? So I'm going to use my graph here and figure out at pi over 2 it's equal to 1. So I've got a third answer of pi over 2. So that's where those zeros happen, which means there's possibilities of inflection points at those points. So now I'm going to scroll down here and insert a new page. There we go, and I'm just going to write the second derivative one more time up here, 2 sine x minus 1 and sine x plus 1, and I'm going to put these on a number line. So this is going to be positive everywhere, and this one, if you graph it, it's let me do it down here, it's a sine wave that's moved up 1, so it's going to look like that. And that means that it's also always positive. So these are always positive, so I'm not going to put these on a number line. And if I graph 2 sine x minus 1, that's a graph that's been moved down 1 with an amplitude of 2. So it's going to look like, here's move down 1 and an amplitude of 2, something like that. So there's two places it crosses over the x-axis, and we figured that out. Those are the roots. That's pi over 6 and 5 pi over 6. So if I go on my number line, if I did it on a number line, it would look like this. Between 0 and pi over 6, it's negative. It's positive between pi over 6 and 5 pi over 6, and negative again over here. That means it's concave down, up, and down. And so concave up between pi over 6 and 5 pi over 6, and concave down between 0 pi over 6 and 5 pi over 6 and 2 pi. So now it tells me that there's two inflection points. One is right here at x equals pi over 6 because it changes concavity, and here at x equals 5 pi over 6. So now I'm going to figure out what the y values are for those inflection points by plugging in pi over 6 into my original equation. So that's 5 cosine of 5 pi over 6, so not 5 pi over 6, pi over 6 minus 2 sine pi over 6. And this was squared. So pi over 6, cosine of pi over 6 is root 3 over 2. And if I square that, and then that's 2 sine pi over 6, which is a half. So root 3 over 2 squared, root 3 times root 3 is 3, 2 times 2 is 4, minus 1, which is negative a quarter. And the good news is that if you put in 5 pi over 6, you get the same answer. So I have two inflection points, one at pi over 6, negative a quarter, and the second one at 5 pi over 6, negative a quarter. And I'm going to put all this information into a graph now.